All right, welcome to the next session, optimizing newstore for massive small object storage. Looks like our presentation is up. You guys want to take it away? Anytime you're ready.
You see the screen now, and can you hear me?
Yep, looks good and sounds great.
Yeah, okay. The motivation of our BP is that we are consistently seeing the small object issue in currently Ceph, and it is not only Ceph, it also happening in Swift. Here's some data we have collected from our previous test. You can look at the 128 KB read and write. The first table is showing that we only have 10,000 of objects there. So the throughput looks good for us. And if we enlarge the data set to 100 million objects, as you can see from the table, the performance degrades a lot. For the read performance, it dropped to only 10% of the small numbers object case, and for write performance, it dropped to only 25% of the previous one. Yeah, we have analyzed block trades before, and it is clearly showing that a lot of small file will overrun the file system, and every rewrite need to go through the horizontal tree. But we have a lot of customers interested in storing a lot of small objects into Ceph as part of their unified storage system. For example, they want in some CDN case they want to cache HTML or something like that, and some other public cloud solution provider they want to store some user photo and something like that. They are relatively small. And the characteristic of their small file storage is that they only do full object read and write, and they rarely delete the object because something like Flickr, you upload the picture, and you rarely delete the picture, and the object is never modified. And they prefer to trade off the space to read-write amplification. That means performance. Say if they doesn't care if you waste some more space, because that compared to the TB level of disk space, the object size is relatively small, and they can afford if you could have 3 or 5 space amplification, but have better read or write performance. Here's some possible solution nowadays we have evaluate try to use some key value store backend for Ceph to store small file, but this approach seems doesn't work because that the large read and write amplification, and especially for level DB and logs DB, the read amplification and write amplification goes up with the total data size. And we also try to cache as much as file system metadata. That is, we are trying to cache inode and XATTR and something like that into an SSD. But the problem is that any caching solution with hint, such as Intel ICAS, that requires some hacking to the kernel, and it will be harder for user to accept that in their production environment. Some other alternatives, say flash cache and bcache, may help some, but since they don't have hint, so the caching ratio is not that good as ICAS. And the third solution is that we can combine a lot of small objects into a single big file. This is what the Taobao has done before. Taobao has a open source project called TFS, which is based on HDFS. That is, they combined a lot of small picture, which is showing only a website, and into a 64 megabyte chunk. So we are considering that if we could do the similar approach, something like TFS. So in newstore nowadays we have that for every object we have an O node, and the O node have a fragment list. So nowadays we only have one object to have one O node, and one O node only have one fragment. The fragment was a file in the file system, but in the fragment structure we really have offset and the length. So what about, let's do this. If we have let's say if we have two small object 1 and object 2, they could have the same they could have different fragment but sharing the same FID. The same FID pointing to the same object, same file in the file system, but the two fragment has different offset and length. So actually, as you can see here, the object 1 has an offset of 0 and a length of 1024. So it actually storing the data in the first 1 KB of the real file, and the object 2 is start from 496 and with the length of 496, so it start from 496, and they are sharing the same physical file in the file system. By doing this, maybe we could have the right process like that. We could have every PG which has an opening fragment, and every new small write will be appended to the end of the fragment. And after the append is done, we could update the O node of the object to make them pointing to the subset of the fragment. And I know that the fragment in the primary and secondary is likely to be different because of some kind of ordering, but it doesn't matter, since that we can do the scrub or whatever in the object base. We don't care the real data placement. And for the real process, we could do like before. We could the O node and the fragment list will pointing us to the right data location. Yeah, this is all I have in this blueprint.
So I may have missed this part. Do you intend to ref count each of the objects so you can tell when the last fragment has been gotten rid of?
Maybe yeah, maybe yes and maybe no, because that as I told before, they don't care. They rarely delete the object, and they don't care the space amplification. So maybe we could do that offline or something like that.
Oh, periodically do a scan, mark the ones that are still in use, and sweep the ones that aren't marked.
Yeah.
Yes. That could work.
That might make sense as a part of the scrub process, even for deep scrub.
Possibly. The trouble is, each PG has one open fragment. Okay, yeah. So PG.
Yeah, because that PG has some kind of locking layer, so maybe we could reuse the PG locking. So the fragment will not be writing twice.
Sure. Yeah, I'm not so worried about that. It just occurs to me that the fragments will not be accessed in object order. They'll be accessed in HObject T order, which means you'll be randomly hopping around between different objects. Still, probably figure something out. because you'd be scanning all of the live HObject-Ts, so you could mark. That's probably doable. Yeah,
Sorry?
I think so. I was
Yeah.
agreeing with Josh. It just took me a minute of babbling out loud to do it.
Yeah.
So, I mean, how small is small here, by the way? Because if they're small enough, you probably just want to stick them in the key in the O node. This is somewhere between that size and big enough to warrant its own file.
Yes.
Okay.
Usually, for example, 128 KB or something like that. That is
Yeah, I
big
think you're right.
enough
You wouldn't
to
want to put that in.
stay in the.
Yeah.
Yeah.
I think you're right. No need to stick to 4 megabyte objects in this case either. So that could be useful. And by object, I mean file, I guess. That's what I meant. No need to stick to 4 megabyte files. They could be bigger.
Yeah.
And you could even hole punch to free up the space. So it wouldn't even necessarily
I just think maybe lots of small objects don't throw at a new store because if one was down and we need to do recover, so we will have a lot of objects needed to recover or scrap. So I think maybe per PG can't have too much object. It is a core, yeah. And maybe we also we handle the file I know that at a new store, but we still have lots of objects at PG or at OSD level. What do you think?
I'm
So
sorry, I
not
didn't
get your
quite
idea.
follow.
Yeah, I mean, where recover, we still have lots of objects. Yeah, we just combine the object to a single file at new store. But if we recover or scrap, we still have lots of objects.
Yeah, that's true. So there's other overhead that would be
That's
bad. But the actual process of getting from duop down to a block on a disk to read will be shorter because we don't have to go through all of the. I mean, I assume that you wrote enough objects that you were sharding. Oh no, you were using. Before, when you were showing the Chaos Bench results, were you using Filestore or newstore?
Filestore.
Right. So with Filestore, you were sharding out to more and more and more subdirectories under each PG collection, which you'd have to do something analogous. Sorry.
Yeah. Yes. That is true.
So that part actually isn't something newstore needs to do because Filestore needs to do that because it uses those directories to list in HObject-T order. Because if you do a directory read on or a list directory on a directory in a file system, you don't get back anything. You don't get back file names in any kind of useful order. You're in XFS and Btrfs, you get them back in some sort of hash order that isn't useful to anyone. So in order to get the first PG object first, we needed to break up the total PG namespace into small enough chunks that we could do a directory listing on the whole chunk and order them. So
Yeah.
320 objects is what we shard at. newstore doesn't have that requirement though, because the file names are not related to the HObject names. We use LevelDB or RocksDB for that. Still though,
Yeah.
this seems like a good idea anyway.
Yeah. Yeah, we didn't test newstore on lots of small files case till now. I think newstore may help in some case because that it could have open by handler or something like that, but it doesn't solve the real problem for the inode extra inode read or something like that.
It's going to solve a lot of it, but not as much as this will. This will take it a step further.
Yeah.
And actually large bits of scrub and recovery are actually pretty happy to work with small objects. recovery will happily combine a whole bunch of objects into one recovery message, and Scrub can too, although we need to adjust the configs.
Okay. I just think the small objects problem is only from Redis Gateway. So do we think actually Redis is designed to large object? So for small object file or object, it is only from Redis Gateway. So maybe we can do this at Redis Gateway level.
How about this? Actually, another case by using libRedis.
Okay.
Yeah, and another problem is I agree that we can do some kind of merging in the Redis gateway level, but the problem is that we need to maintain a mapping between the real object and the merging object, and in Redis gateway there's nowhere for you to store that. If you put that into the old map or something like that, that will also be a trouble.
Besides, there's no real, I can't think of offhand of a really compelling reason why the Rados interface shouldn't work well for small objects. It's just that the OSD was originally tuned not for that. I don't know that it's really a limitation in Rados.
Yeah, but they're discussing that maybe we could do the merging a lot of small objects into a big chunk in the Redis gateway level. So
you certainly could. Well, actually, you'd probably have to do it outside of Rados gateway.
Yeah, if the user could do that's if the user could merge in that before they send them to the Redis gateway, that is perfect. And the second place we can do that is Redis gateway. I don't think Redis gateway is a good place because that you need to maintain another mapping between a real object and the object you stored in the Redis gateway level. That is another kind of metadata layer. And the third place to do that is in the OSD or whatever Filestore, newstore level. That is the third place to do.
Yeah.
I think, we could do that in any
Although
place.
actually, the bucket index could be used to leverage that. I don't think it's worth the trouble, though.
Yeah, but we are seeing a lot of reports on the bucket index issue.
Oh, that's right. You don't want to consult the bucket index on a read. That's right.
Yeah.
No.
Yeah, then the costs in the Rados gateway level are much higher than the costs in the
Rados
level.
Yeah, that's quite true. Yeah, normally I'm the first to suggest that we do it at the client level instead, but in this case, I think there's nothing at all unreasonable with just reducing the overhead. Makes a lot of sense. Are you in a position where you could try? I think newstore's at a position where you could actually perform the benchmark you were doing before against it. Have you considered doing that and then creating a prototype implementation?
Yes. Actually, we are active. Actually, I'm active in integrating into the newstore develop, and but before we are mostly testing on the RBD case. But yes, we can do the Redis gateway tests then.
Well, and if for whatever reason newstore isn't quite able to do Redis GW yet, you could easily replicate those results with small IO. No, actually you wouldn't. But with a C++ program against libRedis, it wouldn't be that hard. If you need to work around some bugs in the current newstore implementation.
Sorry, you mean that using C++ testing?
No, I'm just saying if it turns out that newstore can't, I don't know about it, whether it's able to do Redis GW yet. I think probably it can, in which case it won't matter. But if there are bits of the OSD interface that don't work yet, you could easily work around them by just writing something against librettos directly.
Yes, that is true.
Are we coming to the end of this one, or are we just thinking?
I think we're coming to the end.
All right. Anyone else have anything to add before we move on?
Yes,
All right.
I have done my sharing. Yeah.
Okay, good. Thank you.